Namaste, welcome to my channel Educate Youth. My name is Surya Bahadur and today's topic is round robin scheduling algorithm. So in the previous videos I have already discussed the process scheduling algorithms like your FCFS scheduling algorithm. I have covered SJF scheduling algorithm. Under SJF scheduling algorithm I have covered preemptive SJF scheduling algorithm and non-preemptive scheduling algorithm, and I have also covered the priority scheduling algorithm, and in today's class I will cover the round robin scheduling algorithm. Okay, so in the previous videos I have already discussed the lot of important terms that is required to understand the process scheduling algorithms. Okay, so if you haven't watched my previous videos till now, you can go back and watch my all my previous videos like FCFS, SJF, and priority scheduling algorithms. And in those topics, in those classes, I have discussed lot of important technical terms like what is a program, what is a process, what is a scheduler, what is a CPU scheduler, what is a process scheduler, what do you mean by preemptive, what do you mean by non-preemptive. Okay, so a lot of technical terms I have discussed in my previous videos. You can visit my previous videos and watch those videos, and you will be learning a lot of things in those videos. Okay, so if you have learned all those terms, it will be very much easier to understand the round robin scheduling algorithm. Okay, don't directly jump to the round robin scheduling algorithm. Okay, right? So round robin scheduling algorithm, this particular process scheduling algorithm, this round robin scheduling algorithm is a very important scheduling algorithm. Okay, so in your Windows operating system, this scheduling algorithm is mostly used. Okay, because it is very much effective scheduling algorithm. Okay, why? Because each and every processes will be getting the equal share of the processor to get executed, and there is no chance of starvation. Understanding the word starvation? Starvation is avoided here. Starvation means, see, in case of priority scheduling algorithm, there is a chance of starvation. Okay, in that scheduling algorithm. But in the round robin scheduling algorithm, there is no chance of starvation. Because why? Each and every process will be getting the processor in certain time period. Okay, so no process will be starving for the processor. Okay, understanding the word starvation. So if I give one example, for example, for example, your friend is sitting in front of you. Okay, and he is having a lot of food to eat. Okay, so he is going on eating the food. Okay, and he is going on continuously eating the food, and he is very much satisfied by having the varieties of food, and he is continuously eating the food, and you are just looking to the food. Okay, so your friend is not allowing you to take the food. You are just looking at the food, and you are just trying to understand. You are just starving for the food. Understanding the word starvation, you are just starving for the food. Okay, your friend is not allowing you. He is going on eating. You are just looking at that food. Okay, and finally, what happens? Your friend will be eating, and he is continuously eating, and he is closing the door and making you out, and he is going on eating, and he is not allowing you to eat. Okay, so you are starving, and finally, for example, 2 days has been completed. You are not allowed to take the food. Okay, so due to starvation, you may die also. Okay, due to starvation of food, you are finally dying. Are you understanding? Same case. If a high priority process, in the case of priority scheduling algorithm, okay, if a high priority process is utilizing the processor for the long period of time, that means its execution time is very long. Okay, so it is utilizing the processor for a long period of time. as it is a high priority process and it has entered to the processor and it is consuming the processor for a long period of time. And the low priority process is waiting for the high priority process to complete its execution. Okay, so low priority process is waiting for the high priority process to complete its execution. So low priority process is waiting, and finally what happens that the high priority process is not completing its execution for a long period of time. Due to that, the low priority process which is waiting outside may die, may get lost. Understanding the point? Okay. So that was the case. That means that was the starvation case. Starvation. The low priority process is starving to acquire the processor. Okay. So that case is possible in the priority scheduling algorithm. Okay, that is the disadvantage of priority scheduling algorithm. Starvation, due to starvation, a process may get lost. A process may get die. Okay, that is the starvation, right? That is possible in your priority scheduling algorithm. But in round robin scheduling algorithm, that is totally avoided because every process will be getting their time to get execute in the processor. Okay, understanding? See, round robin scheduling algorithm is a very effective algorithm and here the starvation is avoided. Try to remember that. Okay? And round robin scheduling algorithm is a preemptive scheduling algorithm. Okay? It's a preemptive. So what is preemptive? I have already discussed in details in my previous videos. Okay, so try just go back my previous videos and watch my previous videos. You will understand what is preemptive and what is non-preemptive. Okay, so round robin scheduling algorithm is a preemptive scheduling algorithm. Okay, round robin. Why the name round robin? So it follows the round robin principle, right? It follows the round robin principle. That means once getting the processor coming out, printed out, then another process will be getting the processor printed out, then another process getting the processor printed out. Okay, that means every process will be getting their equal chances to get executed in the processor. Okay, so it follows the round robin principle. So that's why the name round robin scheduling algorithm. Okay, understanding? So in your Windows versions of operating system is having the round robin scheduling algorithm. Okay, mostly popular and widely used process scheduling algorithm is the round robin scheduling algorithm. Okay, so this those process scheduling algorithms are very important in terms of your competitive examinations. Okay, mostly it is being asked in your BTech level courses where your operating system will be operating system subject is there. This questions is mostly asked. Okay, in your competitive examination, in your GATE level examination. Okay, so try to understand the concept. The important thing is the concept. Okay, so if you are understanding the concept, any kind of problem you can solve under round robin scheduling algorithm. Okay, so the important thing is that understanding the concept. Okay, so don't try to skip the videos. Just go through it in details. You will understand in a very better way, and you will not be getting forget for your lifetime also. Okay, so try to understand the concept because once you are understanding means it will be remaining forever in your life. Okay, so understand. Okay, so round robin scheduling. So we are having the process queue. We are having how many processes? Process P1, P2 and P3. Three processes are there and their execute time or the burst time P1 4, P2 3, P3 5. These are the execution time for individual processes, right? And round robin scheduling algorithm follows the FIFO rule, first in first out rule. Okay, so that's why I have generated one queue here, and the three processes has entered into the queue. So which process has entered first, that will be in the first in and that will be first out. Understanding? So P3 has entered first, next P1 has entered, then P2 has entered, and they are in a queue, in a waiting queue to acquire the processor. So here I have shown you the processor. Okay, so here they will be getting executed, and right now they are in a queue. Okay, P3, P1, P2, our three processors. Understanding? Okay, fine. So one thing here you try to understand that in your round robin scheduling algorithm there is a concept of time quantum, or you call it as a time slice. Okay. So what is this time quantum, or you call it as a time slice? This is the time provided to a individual process to get executed. Up to 2 units of time only a single process can get executed. Then it will be printed out. That's why I said you primitive algorithm. Round robin scheduling is a primitive algorithm. Okay. So that means an individual process will be sharing only 2 units of time inside the processor. Okay? Understanding? That's why time slice or time quantum is being given by the operating system to the individual processes. Okay? Whatever the execution time a process is having, that will not be considered. One time slice or the time quantum is given, provided to individual process. That means at a single point of time, a single process can execute for 2 units of time only. Then it has to be printed out. By doing so, what is the advantage of round robin? By doing so, every process is getting the equal chance to get executed in the processor. Understanding? Okay. See. Time slice is 2 units of time here, right? In the round robin. So it may be 3 units of time according to your operating system. Whatever the time it provides, it has to follow that rule only. Okay? That principle only. Okay? So here the operating system is providing 2 units of time for individual process. Understanding? Right. So they are in the queue right now. Okay? So right now which process will be acquiring the processor? P3. Right? P3 will be acquiring the processor. So P3 will be acquiring the processor at the 0 time and it starts execution. Okay? So remember here, it will get only 2 units of time to get executed. Okay? So what is the total execution time of P3? Total execution time is 5 units of time. 5 units of time complete means your P3 execution completes. But the operating system has given, according to round robin scheduling algorithm, individual process will be getting only 2 units of time at a one instance of execution, right? So P3 will be getting only 2 units of time, but it is having 5 units of time to complete P3. Okay, so it will be executing 1, 2. Okay, so 1, 2 units of time completed for P3. So it has to be printed out. Printed out. Okay, so it has completed only 2 units of time. Still 3 units of time is left. 2 has completed. So it has printed out, and where it will be going and storing? Here. Understanding? First in, first out, in a round robin way. Okay, so P3 has completed 2 units, and right now P3 will be getting stored in the queue again, waiting queue. Completed P3, right? Now whose turn? Now P1 turn. So now P1 will enter into the processor, right? P1 will enter into the processor for executing. So what is the total execution time for P1? 4. So it will be getting how much time to get execute? 2 units of time. So P1 will be executing at 3, 4. Up to 4 it will get executed. 4 units of time it will be getting executed, P1. Then it gets printed out. Printed out according to round robin. Okay? So after printed out, so P1 has completed only 2, still 2 is left. 2 unit of time is left. Okay? So it is printed out and it will be going and at the back of the queue. Okay? So P1 will be stored in the queue in this manner. Right? Now whose turn? P2 turn. Now P2 enters and gets executed in the processor. So it will be taking how much unit of time? So what is the total execution time for P2? 3. But it is according to round robin algorithm, how much time it will be getting? 2 units of time. So it will be executing 4, 5, 6. Up to 6 it will be executing and it is printed out. And where it will be showing? Again here. Okay, P2. Got it? Okay. So P2 has completed how much? 2 unit has completed. Still 1 unit is left out. Understanding? Fine. Now P2 has entered, right? Now whose turn to get execute? Now P3 turn. So P3 acquires the processor. Okay. So right now P3 how much time? Still left 3 unit of time, but it will be getting only 2 unit of time. So 6, 7, 8. So at 8 it completes 2 unit of its execution and still remaining is 1. Okay, and after when it completes 8 it will be printed out. Understanding the algorithm, right? So it will be printed out and going and storing over here. P3. Right? So now whose turn? Now turn is P1. P1 will be acquiring the processor. So P1. So how much time is left? P1? 2 units of time. And according to round robin, what is the time slice? 2 unit only. So it will complete its execution here. P1 at 9, 10, P1 complete its execution. Right? 2 units is also completed. Okay? So total 4 units it has executed. Understanding? Okay, fine. So P1 has completed its execution. So no need to in the queue again. Okay? So it has completed its execution. Right? Now, so which one is the next turn? P2. Okay? So P2 will be acquiring the processor. Right? So what is the left out execution for P2? Only 1 unit is left out. But time it is getting 2. So around say it will be completing its execution. Right? So P2 at 11 it will complete its execution. Okay? So P2 has also completed its 3 units of execution. Right? Now P2 has completed. So no completed means over. Now no need to come and sit in the queue. Okay? So now the final process which is left out is P3. Okay? So now P3 acquires the processor at 11th time. Okay? So what is the total time left for completing P3? Only 1 unit is left. Okay? 2 has already completed. Only 1 is left. Okay? So it will be completing at 12 unit of time P3. Okay? So P3 also completed its execution. Okay? So understood here. No process is starving for the processor in the round robin, right? No process is starving for the processor. Every process is getting the equal chance to get executed. Okay, understanding? But in case of your SJF or even the priority scheduling algorithm, that was not the case. One process will be executing in the processor, another process is waiting, and the situation of starvation occurs there. But the situation of starvation does not occur here in case of round robin. That's why the round robin scheduling is the mostly accepted scheduling algorithm, process scheduling algorithm. Okay. So in the Windows version of your operating system, you will be definitely getting the round robin scheduling algorithm. Okay, right now. So all the processes has completed its execution. Got it? Got the concept? Okay, fine. Right now. So what is the waiting time? Okay, so now we need to calculate the waiting time. So we are having the process waiting. So we are having how many processes? P1, P2 and P3. Right? So what is the waiting time for process P1? Okay? So what is the total waiting time for process P1? How much time it is waiting to complete its full execution of 4 units. Okay, so that is the waiting time for process P1. Okay, so what is the waiting time for process P1? So let us calculate. So process P1 has started at 2 unit of time, right? So up to what? It has waited up to 2 units because P3 was executing, right? So P1 waited for 2 here, right? It has waited for 2 units of time. Okay, so it has completed 2 units of its execution at 4. So again it is executing, it is getting the processor at 8 unit of time. Okay, so it is waiting for how much here? 1, 2, 3, 4 unit. P1 is again waiting for 4 unit, right? So 1, 2, 3, 4. 4 unit it is still waiting because it has not completed fully. Okay. So again at 8 it has started execution. Okay. So here 2, here 1, 2, 3, 4. So 4. So 2 plus 4. So it has totally waited for 6 unit of time. Understanding? Next. So what is the total waiting time for process P2? P2, see here. P2 started its execution at 4 unit of time. Right? So it has waited for how much time? It has waited for 4 units already because P3 and P1 were executing. So it has already waited 4. Okay. So it completes its 2 unit of execution at 5 and 6. Again it is starting at 10. So from 6 to 10 it is waiting again. Right? So how much unit it is waiting? 6 to 7, 1, 2, 3, 4. Again 4 unit it is waiting. So 4 plus 4, 8 unit P2 is waiting totally. Okay. So what is the total waiting time for P3? So P3 has started at 0. So it is not waiting here. Right. So it is completing its 2 units over here. So from here again it is waiting up to here. That means how many unit of time it is waiting? 1, 2, 3, 4. Up to here it is waiting 4 unit of time. So P3 up to 8 it is executing. Acquire the processor. Again from 8 it is waiting up to 11. Right? So how much unit it is waiting? 1, 2, 3. So 4 plus 3. 7 unit of time totally P3 has waited. So what is the average waiting time? Average waiting time. What is the average waiting time? 6 plus 8 plus 7 divided by how many processes? 3 processes divided by 3. Okay. So how much? 21 by 3. So what is 7? 7 unit of time. Okay. So understood? So this is the total average waiting time for all the processes. Okay. So this is all about your round robin scheduling algorithm. I hope you understood the basic concept of round robin scheduling algorithm. Okay. And the most important thing of the round robin scheduling algorithm is that it is starvation free. Though no process will be starving for the processor. Okay. So So that is only the concept over here. Okay. So I hope you understood the round robin scheduling algorithm. Okay. So in next class we will be discussing about the deadlock concepts. Okay, deadlock concepts.